We're now going on to topic 3.2, which again is dealing with systems of equations in two variables. And as a quick review of what we did in 3.1, we said we were going to use the graphing technique, in which we made a graph and then saw, in this case, that it's going to intersect in one place at the coordinates x comma y. Another time we might make a graph in which it looks like this. The lines are parallel, so there's never going to be an intersection. So we say for that there is no solution. And then the other option was in which you had a line, and then when you graphed the other line, it was on top of that one. So the number of ordered pairs for one were the same for the other. So we say it's an infinite number of solutions. And then in set builder notation, we write it x comma y is such that, and you list one of the equations. Here I've listed one in slope-intercept form. Now there are two other methods, and one of the things I did point out toward the end of the other video was that graphing is difficult because you have to be very careful with the lines and you're trying to pick out where they intersect. So if you don't make your lines carefully and you don't have graph paper, it's really difficult to do. So there are other methods. And again, I'm doing this before we actually have the class, but the two other methods I have listed here. One is called substitution, and the other method is called elimination. And what we're doing here is we're trying to end up with an equation with only one letter variable. Well, here there's an x and a y, here there's an x and a y, here there's an a and a b, here there's an s and a t. But we want to eliminate one of the letters. And one way to do it is through substitution, which I will illustrate. And the other one is elimination. So if you had the lesson, what we were looking for is, for 1 through 4, is to pick out which method would you use if you had this system of equations. And there are 4 systems of equations here. Now, the basic rule for doing these was to sort of set them up in standard form and then look at them and think about it. And one of the methods were to draw a line underneath it and then add them up. So if we added up this particular system of equations, what we would have here is 8x as we add this up. Here, these would cancel out because they're additive inverses of each other. And then this would add up to 10. So we'd have 8x equals 10. We have eliminated the y's. So for number 1, we would use elimination. Now as we look at number 2 is not set up in standard form, but notice it solves for the letter y. So if we take this value of y in terms of x and substitute it there, we would end up with an equation 6x plus y, but we know y is 4x minus 7, and that equals 9. We have used the principle of substitution, where we substituted a value for the other variable, and y is this, so we take this and put it where y is, and that's what we've done right there. And now we have an equation with only one variable. So for number 2, we would use substitution. Again, a key to use of substitution is where you have y by itself, or sometimes it's x by itself. And we'll see some examples as you do the practice and the quiz bees, and I'm going to do some of those examples in a few minutes. So for number 3, it's in standard form, and notice nothing seems to cancel out, but there's no easy way to solve for either a B or A. So we wouldn't use substitution here. We would use elimination. Now, let's go over how we would do it. Well, we want to, let's say, get the A's to cancel out. Okay, well, one of the things we would do is rewrite it in standard form. It's not quite standard form. In fact, let's rewrite it here. This is 6A minus 3B equals 7. Remember, our ordered pair in this case is AB. So this one, we'd have to use negative 6A. Notice lining up the A's, plus 2B equals 1. All right, so we had to put that in standard form. Now, we see when we put our line, these are going to cancel out. And we're going to end up with negative B equals 8. And we're solving it, even though they ask, we don't need to solve it. And then a positive B, just divide both by a negative 1, B would equal a negative 8. So once we find one letter, we then put the negative 8 in either of our equations, solve for the other letter. But here they're only asking us what technique would we use, substitution or elimination. Now in this one, it's sort of lined up, S's and T's, but nothing cancels out at this stage. So, and again, there's no S or T by itself, so we get a nice equation like this that we could use substitution. So for number 4, we're going to use elimination, but in order to eliminate something, we're going to have to modify one of the equations. So this equation, in order for my negative 4t to cancel out, I'm going to have to increase this whole equation by multiplying every term by 2. So here's what we now get. 5s minus 4t equals 3. So this equation, we make no changes to it. But this second equation, I am allowed to multiply everything by something. It's not the same equation, but it is an equivalent equation. So by multiplying this by 2, I get here 6s. Multiplying this by 2, I get a positive 4t, and that's what I was looking for. And then I have to multiply this by 2, and I get 14. So now I have changed this second equation. I've made it an equivalent equation, but now the t's cancel out. And I end up with 11s equals 17. Now we're not asked to solve this one, but we're just asked what method would you use? And again, this was elimination, substitution. This one was elimination. You had to rearrange things. And this one you had to modify the second equation, and we'd use elimination. Okay? Now notice we didn't get any answers yet. We're just looking for strategy. Which method are we using? And notice we're going to get a fraction here. I think there's a couple of places where we're going to get fractions. Now in example 5, they actually want us to work something out. And 5 and 6, they want us to use substitution. And notice it's set up for substitution because y is solved. This is in slope-intercept form. So what I do is I take this value of y, put it in the other equation. So it'll be 3x, that's what we have, plus 2. Now they want a value for y here, and there's our value for y. 2x plus 6, and then this equals 5. So now through substitution, I have substituted for y in terms of x. So I go to my other equation, and where I have a y, I put this value there. And now I have an equation with only one letter. And the technique I'm using is substitution. So now I clear parentheses. This goes back to our chapter 1 work. Have to be careful of the signs. And then this gives me a 7x. And I bring my 12 over as a negative 12 on the other side, transpose, and that gives me a negative 7. So I have negative 7x equals negative 7. I'm going to divide both sides by 7. I get x equals negative 1. I now have one member of my ordered pair. I know that x equals a negative 1, so I go back into my, perhaps the other equation. You could use either one. Put my negative 1 where the x was. This is 2 times negative 1 is a negative 2, plus 6 gives me a 4. And that is my ordered pair. That's where these two equations would intersect at that particular point. And this would be a solution for either equation. Again, they want us to do this by substitution. And notice you have s all by itself. But you want to solve for s. So we'll put s equals, we'll transpose this term. That gives us a positive 6t plus 5. So now we have a value for s in terms of t. We go to our other equation, and where there's an s, we put this in there. So it's going to be 3 times our value for s, which is 6t plus 5, plus 2t equals 0. And again, lots of techniques from solving equations. So we get rid of our parenthesis, 18t plus 15 plus 2t equals 0. We group like terms. That gives us a 20t. I'm going to transpose the 15 to the other side. That gives me a negative 15. And again, we're using lots of techniques from previous chapters. And now we're going to divide both sides by 20. I get t equals a negative 3/4. So once again, we had two equations. These were system of equations. We're using the technique of substitution where we solve for the letter s. We then take that value, put it in our other equation where s is. You have to use parentheses, as you have to clear the parenthesis by the distributive principle as needed here. Collecting like terms, transpose, divide by the numerical coefficient, so there is one ordered pair. Now, this happens to be the y term, so to speak, so that goes in the second position. Now we have to solve for the x term, or in this case, the s term. So, what equation should we use? Well, I would use this one. I'm going to erase some of the work so it's a little more clear. So here we solve for our t term, and we got a negative 3/4. So we're using this equation, and where t is, I've put in a negative 3/4. I did some canceling out. 2 will go into 4 twice. 2 will go into 6 3 times. So I now get a negative 3 times 3 is a negative 9 over 2. Now I have to add that fraction to 5. In order to do it, I have to think of making this denominator a 2. So I multiply it by 2, a technique from chapter 1. This gives me 10 halves. 10 halves is 5. But now I can add the fractions, or in this case subtract. A negative 9 plus 10 is a 1 over 2. So my s term is 1/2, and that is correct. Now keep in mind, if you had to graph this, that would be very difficult picking out those ordered pairs. And you want to be able to do something like that. That is challenging. In number 7, here we have x equals something. But we're going to do a little manipulation here. We're going to put this in standard form. So this comes over as a negative x. My 3y stays there. And this goes over as a negative 4. So our positive x goes to the other side as a negative x. This stays there and my 4 goes. So that's in standard form now. I'm going to put this one in standard form. Now we're going to use the elimination method for this one. But notice if I put a line underneath them to add them up, nothing cancels out. But if I multiply this second equation by a negative 1, what happens? Well, my signs change. This will become a positive, this will become a negative, and this will become a negative. So, again, it's not the same equation, but it's an equivalent equation because I've multiplied it by a negative 1. Now watch what happens. This cancels out. This cancels out. So I have a 0 equals negative 9. Now is this true? And as we said the other day, no, it's not true. When it's not true, when you get something like this, you have a condition where these lines are actually parallel. So for this example, number 7, there is no solution because the lines are parallel. Whenever you get a false statement here, that's the case, the lines are parallel, there's no solution. And we had said when you get like a 0 equals 0, which is a true solution after doing this, then it's the same lines, and you say infinite number of solutions or use set builder notation and use one of the equations. But in this case, it's untrue, so no solution, the lines are parallel. As we go on to number 8, we look and say, well, what method should we use? Now, we could use elimination. They're not in the right form to do it. Or we could use substitution. Because look at, they're saying B equals something. So let's use substitution. So this is going to be 6a minus 2. There's our 2. And then they're saying B is this. So I put it in parentheses. And we're saying that equals 6. So we took this value of B and substituted it right there. Now we clear parentheses. 6a minus 6a plus 6 equals 6. Now notice an interesting thing happens here. We get 6a minus 6a, that's going to cancel out. That's going to give you 0 plus 6 equals 6. Now notice here, we're getting 6 equals 6. Is that a true statement? And the answer is yes. So actually what we have here, these two equations are the same. They're just in different forms. So the answer to this would be, they're the same lines, infinite number of solutions, or you can write it. In this case, they're using a comma b is such that, and we can use this equation here, b equals 3a minus 3. Because this equation is the same as that equation, it's just in a different form. Now if you had done it through elimination, everything would have eliminated and you would have ended up with 0 equals 0. Same answer though. When you get a true statement at the end, there's no more letters, either 6 equals 6 or 0 equals 0, it's an infinite number of solutions, it's the same line, just in different presentations. In number 9, again, they're asking us to use now elimination here. We could have used substitution too, but it lends itself to elimination. They're both in standard form. We put a line underneath them, and then our y's cancel out. So we then get, let's do that correctly, negative 5 and a positive 3, a negative 2x. So just adding these up, we get a negative 2x equals 6. And we're going to divide both sides by a negative 2. We get x equals, and again, be sure to put the negative there, a negative 3. So there's our first member of our ordered pair. We still have to find the y. So we could use either equation. We know that x is a negative 3. So 3 times negative 3 was going to give us a negative 9 minus y equals 3. So my first value, x is a negative 3. I put that here. Negative 3 times 3 is negative 9. Minus y equals 3. So I'm going to transpose this. This becomes a positive 9 on that side. So I have negative y equals 12. And we know if we just divide by 1, a negative 1, we get y equals a negative 12. opposite sign. So there are our ordered pair. Again, dividing this by a -1 gives me a -12. And when you put that into your practice at QuizBee, it's sort of your check. In example 10, as we look at them, they don't look like the same equation. And it doesn't look like it's easy to do substitution. And nothing's going to cancel out right away. So what we want to do is to multiply something so that one of these lines cancels out. So here, let's say if we multiply this equation by a 3, I'll put that up there, that's going to make this a 36. If we multiply this equation by a -4, that's going to make this a -36. So let's do that. So 3 times 8a is going to be 24a plus 36b equals 30. Now, in this one, we're going to multiply it by a -4. This is going to be a -24. Oh, something interesting is happening here. This is a -36b. And this is going to be a -20. Do you see the interesting thing that's going to happen? Here, these cancel out, these cancel out, so I have 0 equals 10. Is this a true statement? And the answer is no. So, when it's not a true statement, these lines are parallel. And so there is no solution. Okay, what we wanted to do in this tape is to illustrate substitution, elimination for solving systems of equations. And we've done all the possibilities. The rest are just working them and giving it your best shot. So we'll call this the end.